Okay, so get this. Today we're diving into some machine learning research that was literally just published.
Oh, wow.
Yeah, we're talking papers from rcv.org dated January 9th, 2025.
Like hot off the presses.
Exactly. It's like a sneak peek into the future of AI, and you're coming along for the ride.
Always exciting to see what's new.
It really is, and we've got a lot to cover today.
Looking forward to it.
So we've got everything from, neural networks learning to deal with uncertainty to the surprising comeback of simpler models for predicting things like stock prices or the weather.
Interesting.
And get this, AI is even being used to tackle big challenges like climate change and medical diagnosis.
The range of applications is really remarkable.
It really is. It seems like AI is everywhere these days.
It's true. It's touching so many different fields.
Okay, let's start with this paper about neural networks.
Okay.
Specifically how they handle uncertainty. It's called On Weight and Variance Uncertainty in Neural Networks for Regression Tasks.
Catchy title.
Yeah, well, researchers...
Gotta love those research paper titles.
So we know neural networks are powerful.
Incredibly powerful.
But even the best ones can have trouble with uncertainty.
Yeah, that's a fundamental challenge.
And that's a big deal if we're using them for things like, self-driving cars.
Right.
Or medical diagnoses where we need them to be super reliable.
Absolutely. The stakes are high.
Exactly. So we need to know how confident they are in their predictions.
Makes sense.
And what this research found is that by specifically accounting for that uncertainty, the predictions actually become more accurate.
Interesting. So embracing the uncertainty actually helps.
It seems counterintuitive, right?
Yeah.
But it's like the network is learning to double-check itself.
Right.
Which leads to more reliable results.
So it's more cautious, more aware of its own limitations.
Exactly, especially when faced with data it might not have encountered before.
Yeah, like new situations, new patterns.
Exactly. So that's really important for things like medical diagnoses where you don't want the AI to be overconfident.
You want it to flag potential issues, say, hey, I'm not sure about this one.
Right. Get a second opinion.
Exactly.
That makes a lot of sense.
It does this.
Okay, now for something completely different.
Okay, I'm intrigued.
This next paper is all about time series forecasting.
Time series. So like predicting the future based on past data.
Exactly. Predicting what's going to happen next based on past data.
Right, like stock market predictions, weather forecasting.
Exactly. Or predicting energy consumption, all sorts of things.
It's a crucial area. Lots of applications.
And you'd think we'd need super complex models for that.
Yeah, with all the intricacies of time and trends.
But this paper suggests that sometimes simpler is better.
Oh, interesting. Going against the grain.
They've developed this new system called linear.
Linear.
Yeah, and it uses a simpler model, but it's incredibly effective.
So it's like a David and Goliath situation.
Kind of, yeah. It's challenging the assumption that more complex always equals better performance.
It's a good reminder that sometimes elegance and simplicity can win the day.
And what's fascinating here is that G-linear is not only simpler, but it also needs way less data to train.
That's a big advantage, especially in a world where data is so valuable.
Exactly. In a world where data is everything, that's a huge advantage.
For sure, less data, less time, less resources needed.
So it's like this model is a quick learner.
Picking up on patterns quickly.
Yeah, picking up patterns and making accurate predictions without need a ton of examples.
That opens up possibilities for fields where data is scarce or expensive to collect.
Exactly. Imagine the possibilities.
Lots of potential applications there.
And what's even more surprising is that in some cases, G-linear actually outperforms those big, complex, deep learning models like transformers.
Wow, that's impressive.
It's a real testament to the power of elegant design and a deep understanding of the problem.
Sometimes it's not about brute force computation. It's about understanding the underlying principles.
Now let's switch gears and talk about large language models, or LLMs.
LLMs, the talk of the town these days.
You've probably heard of GPT-4.
Of course, who hasn't?
Which is amazing at understanding and generating text.
It's revolutionized the way we interact with language.
But what if we could take that a step further?
How so?
And bridge the gap between language and things like images or even emotions.
Interesting. So going beyond just text.
Exactly, making AI more multimodal.
Multimodal AI, that's the future.
That's what this next paper explores.
What's it called?
It's called OpenOmne. Large language models pivot zero-shot omnimodal alignment across language with real-time, self-aware, emotional speech synthesis.
Another catchy title.
Yeah, researchers love their long titles.
So tell me more about this OpenOmne.
They introduce OpenOmni, an LLM that goes beyond just text.
So it can understand and process other types of data.
Exactly. Imagine an AI that can look at an image, understand what's happening, and then describe it to you in a way that conveys the emotions involved.
That's pretty amazing. Like it's actually understanding the emotional content of the image.
It's taking the power of language and combining it with the richness of visual information and emotional intelligence.
It's like it's tapping into a whole new level of understanding.
And here's the really exciting part.
What's that?
OpenOmni is open source.
Open source, that's huge.
That means anyone can access it.
Use it, build upon it.
This has the potential to truly democratize access to advanced AI technologies.
Especially in fields like education, healthcare, creative arts.
Exactly. The possibilities are endless.
It's game changer for sure.
Okay, so how does this OpenOmni thing actually work?
It sounds pretty complex.
It is complex, but I think I can explain it in a way that makes sense.
I'm all ears.
So it involves a two-stage training process.
Okay, 2 stages.
First, it learns to connect different types of data like text, images, and speech without needing explicit examples for every possible combination.
That's interesting. So it's learning to generalize.
It's a bit like teaching a child to recognize a cat in a picture,
Oh, okay, I can see that.
even though they've only ever seen a real cat before.
So it's developing a deeper, more intuitive understanding of how these different forms of information relate to each other.
Exactly. It's not just memorizing patterns.
It's learning the underlying concepts, the relationships between different modalities.
And then in the second stage,
What happens then?
OpenOmni learns to generate realistic speech,
So that's where the speech synthesis comes in.
complete with different emotions.
So it can sound happy, sad, angry, all those nuances of human emotion,
Exactly. It could potentially change the way we interact with AI.
making those interactions more natural and engaging,
Imagine having a conversation with an AI that not only understands what you're saying,
but also how you're feeling.
it's like taking a step closer to truly human-like AI.
It's both exciting and a little bit unnerving.
Yeah, it raises a lot of interesting questions about the future of AI and its role in our lives.
No doubt about that, we're entering uncharted territory.
But it's a journey worth taking.
Absolutely, the potential benefits are enormous.
Okay, so we've seen AI tackling uncertainty, predicting future trends,
Right.
and understanding the connections between different types of data.
It's been quite a tour so far.
It has, and we're just getting started.
Bring on the next batch of papers.
I'm with you. Let's dive in.
Let's do it.
Yeah.
That's right. So much to cover, no time for breaks. Let's move on to a paper that explores how we can make AI systems work together more effectively, even when they don't have access to each other's data directly. It's a technique called federated learning, and it's particularly relevant in fields like healthcare, where data privacy is paramount.
Federated learning, I've heard that term before, but can you remind me how it works?
Imagine you have multiple hospitals, each with their own patient data that they can't share due to privacy regulations. Federated learning allows them to train a single AI model collectively without actually exchanging the raw data.
So it's like each hospital trains its own little piece of the AI, and then those pieces are somehow combined to create a super smart model that benefits everyone.
Exactly. In this paper, Federated Learning and RAG Integration, a scalable approach for medical large language models, takes this concept a step further by integrating a technique called retrieval augmented generation, or RAG.
Raggy. That sounds intriguing.
It's essentially a way to give these medical language models access to a vast library of external knowledge. Imagine giving a medical student access to a comprehensive medical textbook while they're learning. That's what RAG does for these AI models.
So it's like supercharging their knowledge base so they can make even more informed decisions. That makes a lot of sense, especially in a field as complex as medicine.
The researchers found that by combining federated learning with RAG, they could significantly improve the performance of these medical language models on a variety of tasks. And because it uses federated learning, they could do all of this while still protecting patient privacy.
It's incredible to think that we can now train powerful AI models to assist with medical diagnosis, treatment planning, and even drug discovery, all while keeping patient data secure. This could really revolutionize healthcare.
It has the potential to democratize access to specialized medical knowledge and ensure that patients all over the world can benefit from the latest advancements in AI-powered healthcare.
Speaking of pushing boundaries, this next paper, IELBench, a new benchmark for linguistic reasoning, introduces a new benchmark called IELBench, designed to test the limits of AI systems in terms of linguistic reasoning.
It's like an IQ test for AI, but specifically focused on language. The tasks in this benchmark require AI systems to understand syntax, morphology, semantics, all those complex elements of human language that we often take for granted.
It sounds incredibly challenging. So how did the AI systems fare on this linguistic Olympics?
Well, even the most advanced AI systems struggle with some of these tasks. It really highlights the fact that true language understanding goes far beyond simply processing words and sentences. It requires a deeper level of cognitive ability that AI is still striving to achieve.
It's a good reminder that while AI has made incredible progress in recent years, there's still a lot we don't understand about human intelligence and how to replicate it in machines.
This benchmark is valuable because it helps us identify the areas where we need to focus future research efforts. It's like a roadmap for the next generation of AI systems.
Now, for something a little different, let's talk about optimizing the learning process for large language models. This next paper caught my eye because it involves a concept you might be familiar with from the world of websites: SEO.
SEO. You mean search engine optimization? What does that have to do with AI?
That's exactly what I thought when I saw the title of this paper: SEO, Stochastic Experience Optimization for Large Language Models. But it's not about optimizing websites, it's about optimizing the experiences that a language model is exposed to during training.
So instead of focusing on keywords and backlinks, we're talking about curating the data and tasks that the language model learns from.
Precisely. The researchers developed an iterative approach that identifies and prioritizes experiences that lead to better performance on specific tasks. It's like creating a personalized curriculum for the language model, tailored to its strengths and weaknesses.
That's a fascinating approach. It's like those personalized learning platforms that adapt to a student's individual learning style and pace.
The results are pretty impressive. They found that this SEO technique could consistently improve the performance of large language models across a variety of tasks. And what's particularly appealing is that it doesn't require any changes to the underlying structure of the language model. It's all about finding the right learning materials and training regimen.
It's a testament to the fact that even with incredibly complex AI systems, sometimes the most effective solutions are the simplest. Now, are you ready to delve into the world of multimodal large language models, or MLLMs? These are models that can understand and process not just text, but also images, audio, video, the whole multimedia shebang.
MLLMs, they sound incredibly powerful, but I imagine it must be quite a challenge to train a model to understand and connect all these different types of data.
You're absolutely right. And that's precisely what this paper, How to Bridge the Gap Between Modalities, survey on multimodal large language model, delves into. It provides a comprehensive overview of MLLMs, the key challenges in their development, and the latest advancements in this exciting field.
I'm particularly intrigued by the concept of modality alignment that you mentioned. It sounds like a key hurdle in creating truly versatile MLLMs.
Modality alignment is all about bridging the gap between different types of data, like teaching an MLLM to see the connection between an image of a cat and the word cat, or between a piece of music and the emotions it evokes. It's like teaching a child to understand that the word apple refers to both a picture of an apple and the actual fruit they can hold in their hand.
So it's about standardizing the input, making it easier for the MLLM to digest information regardless of its original format.
Exactly. Then we have multimodal perceivers, which focus on enhancing the MLLM's ability to perceive and interpret different data modalities directly. It's like giving the MLLM specialized sensory organs that allow it to see, hear, and feel the world in all its richness.
That's a fascinating approach. It's almost like we're trying to mimic the human brain's ability to process information from multiple senses simultaneously.
You're catching on quickly. The third group is called tool learning. It involves using external tools to convert data into a common format, typically text, which the MLLM can then process. It's like giving the MLLM a toolbox filled with specialized instruments that it can use to analyze and understand different data types.
So instead of teaching the MLLM to understand everything directly, we're giving it the tools to translate and process information from different domains. That's a clever approach.
Finally, there's the data-driven method, which focuses on training the MLM on massive data sets that are specifically designed to teach it about the relationships between different modalities. It's like immersing a child in a rich and diverse environment filled with sights, sounds, textures, and smells so they can learn to make sense of the world around them.
It sounds like the MLM is learning by example, by observing how different types of data relate to each other in the real world.
Exactly. And this paper provides a great overview of all these different approaches and the challenges that still lie ahead in developing truly versatile and powerful MLLMs.
It's clear that MLLMs are still in their early stages of development, but the potential is truly mind-boggling. Imagine a future where AI can seamlessly understand and generate language, images, music, and video, all while interacting with the world in a way that feels natural and intuitive. It's a future that I, for one, am incredibly excited about.
As am I. It's a future where the lines between human and machine intelligence may become increasingly blurred, opening up a world of possibilities that we can only begin to imagine. And the research we've explored today is paving the way for this exciting new era.
Now, let's turn our attention to a paper that focuses on one of the most common and often frustrating medical procedures, the MRI scan. The paper is titled Deep Unfolding Network with Spatial Alignment for Multimodal MRI Reconstruction.
I think everyone who's ever had an MRI can relate to the experience of lying inside that noisy, claustrophobic tube, wondering when it's finally going to be over. And for many patients, it's not just one scan, but multiple scans, which can prolong the discomfort and anxiety.
You're telling me. I still have nightmares about that whirring sound and the feeling of being trapped. But this paper suggests that AI could help improve the MRI experience. Tell me more.
This research focuses on using AI to speed up the MRI process, specifically for multimodal MRI, where multiple types of scans are taken. The goal is to reduce the amount of time patients have to spend inside the scanner while still capturing all the necessary information.
That would be a huge improvement. So how are they using AI to achieve this?
They've developed a system called DUNSA, which stands for Deep Unfolding Network with Spatial Alignment. It tackles a common challenge in multimodal MRI, misalignment between different scans. Even the slightest movements during the scanning process can cause the images from different modalities to be misaligned, making it harder to interpret the results.
So it's like trying to solve a jigsaw puzzle where the pieces don't quite fit together properly. I can see how that would be a problem.
Exactly. DUNSA uses AI to automatically align these misaligned images, making the reconstruction process much more accurate and efficient. Imagine having an AI assistant that can automatically correct for any subtle movements or variations in the scanning process, ensuring that the final images are clear, sharp, and perfectly aligned.
That would be incredible. Not only would it make the MRI experience more comfortable for patients, but it could also lead to faster diagnoses and more targeted treatments. I'm really impressed with how researchers are applying AI to solve real-world problems like this.
Me too. It's a testament to the power of human ingenuity and our ability to harness the power of AI for good.
Okay, so we've seen AI being used to optimize the learning process for large language models and to improve the efficiency and accuracy of MRI scans. Now let's shift gears and explore a paper that provides a great introduction to a fascinating area of AI research, diffusion models. The paper is titled Tutorial on Diffusion Models for Imaging and Vision.
Diffusion models have been making waves in the world of generative AI, particularly for their ability to create incredibly realistic images, videos, and even audio. Have you ever seen those AI-generated images that look so real you can hardly tell they weren't created by a human artist?
I have. They're truly mind-blowing. But I have to admit, I don't really understand how they work. Can you shed some light on the magic behind these diffusion models?
Imagine taking a perfectly clear image and gradually adding noise to it until it becomes pure noise. That's the diffusion process. Then you train a neural network to reverse that process, essentially teaching it to denoise the image and recover the original image from that noisy mess.
So it's like taking a perfectly clear photograph, turning it into a blurry mess, and then training an AI to magically restore it to its original state. It sounds counterintuitive, but I guess that's the beauty of AI. It often finds solutions that we humans would never think of.
Exactly. And by learning to reverse this diffusion process, the AI model essentially learns the underlying patterns, instructions of the data it's trained on. This allows it to generate entirely new data that is similar in style and content to the data it was trained on, but is still unique and original.
It's incredible to think that by learning to undo a process of destruction, these diffusion models are actually learning to create something entirely new. It's like a phoenix rising from the ashes. I'm really curious to learn more about the technical details behind these models.
This tutorial paper is a great place to start if you're interested in diving deeper into the world of diffusion models. It provides a comprehensive overview of the key concepts, techniques, and applications of this fascinating and rapidly evolving field.
Well, we've come to our final paper for today, and it's one that brings us back to large language models, or LLMs. It's a survey paper titled A Survey on Large Language Models with some insights on their capabilities and limitations.
LLMs have been a recurring theme throughout this episode, and for good reason. They represent a major leap forward in AI, demonstrating an unprecedented ability to understand and generate human language. But as this paper highlights, there's still much to explore and understand about these powerful tools.
I'm particularly interested in the limitations of LLMs that this paper discusses. We've seen how impressive these models can be, but it's important to remember that they're not perfect. What are some of the key challenges that researchers are still grappling with?
One of the biggest challenges is ensuring that LLMs are both accurate and reliable. They can sometimes generate text that is factually incorrect, logically inconsistent, or even offensive or harmful. It's like having a student who can write beautifully crafted essays, but sometimes makes careless factual errors or inserts their own opinions where they don't belong.
So it's not just about teaching these models to be eloquent, it's about teaching them to be responsible and trustworthy.
Exactly. And another significant challenge is the computational cost of training and running these massive models. They require enormous amounts of data and computing power, which raises concerns about their environmental impact and accessibility.
Uh,
Not everyone has access to the resources needed to train or even use these cutting-edge models.
those are important considerations. It seems like there's a constant tension between pushing the boundaries of AI capabilities and ensuring that these technologies are developed and used responsibly and sustainably.
It's a delicate balancing act, but one that we must strive to achieve. The future of AI depends on our ability to create not just powerful, but also responsible and accessible technologies that benefit all of humanity.
Well said. It's a great reminder that the progress we make in AI should be measured not just in terms of technological advancements, but also in terms of its positive impact on society and the world around us.
This survey paper provides a valuable overview of both the exciting capabilities and the ongoing challenges in the field of LLMs. It's a must-read for anyone who wants to understand the current state of the art and the key questions that researchers are still grappling with.
It's clear that LLMs have the potential to revolutionize the way we communicate, learn, and interact with the world around us. But it's equally clear that we need to proceed with caution, carefully considering the ethical and societal implications of these powerful technologies.
It's a sentiment I wholeheartedly agree with. Now, let's move on to a paper that explores how we can use AI to gain a deeper understanding of complex systems, such as the human brain. It's titled Deciphering the Neural Code, a deep learning approach to brain-computer interfaces.
Brain-computer interfaces. That sounds straight out of science fiction. Are we talking about mind reading here?
Well, not quite mind reading, but we're getting closer. Brain-computer interfaces, or BCIs, allow us to connect the human brain directly to computers, enabling us to control devices with our thoughts, or even to decode the neural signals that represent our thoughts, emotions, and intentions.
That's incredible, but I imagine it must be incredibly difficult to decipher the complex language of the brain. How are they using deep learning to crack this neural code?
This paper proposes a novel deep learning architecture that can learn to map patterns of neural activity to specific thoughts or actions. It's like training an AI translator that can convert brain waves into a language that computers can understand.
So instead of trying to program a computer to understand the brain, we're teaching an AI system to learn the brain's language on its own.
Exactly. It's a more data-driven approach that leverages the power of deep learning to unravel the complexities of the brain. The researchers found that their deep learning model could accurately decode neural signals related to movement and tension, allowing them to control a robotic arm with remarkable precision simply by thinking about moving their own arm.
That's mind-blowing. It sounds like we're on the verge of a paradigm shift in how we interact with computers in the world around us.
Imagine a future where people with paralysis can control prosthetic limbs with their thoughts, where we can communicate directly with computers using our minds, and where we can gain a deeper understanding of the inner workings of the human brain. BCIs hold immense potential for both medical and technological advancements.
It's a future that both excites and challenges us to think carefully about the ethical and societal implications of such powerful technologies. We need to ensure that these advancements are used responsibly and for the benefit of all humankind.
I couldn't agree more. Now, let's shift our focus to a paper that explores a different kind of intelligence, the collective intelligence of social insects. It's titled Ant Colony Optimization for Complex Network Routing, a deep reinforcement learning approach.
Ant colony optimization. That sounds intriguing. What can we possibly learn from ants when it comes to complex network routing?
You might be surprised by how much we can learn from these tiny creatures. Ant colonies are incredibly efficient at finding the shortest paths between their nest and food sources. Even in complex and dynamic environments, they achieve this through a process of pheromone-based communication and collective decision-making.
So they're basically nature's network routing experts.
Precisely. And this paper proposes a new approach that combines ant colony optimization with deep reinforcement learning to develop more efficient routing algorithms for complex networks like the internet or transportation systems.
It sounds like they're taking inspiration from nature to solve some of our most challenging technological problems.
That's the beauty of biomimicry. We can often find elegant and effective solutions to complex problems by looking to the natural world. The researchers found that their ant-inspired routing algorithm outperformed traditional methods in terms of both efficiency and robustness, particularly in dynamic environments where network conditions can change rapidly.
It's fascinating to see how AI research is drawing inspiration from such diverse fields, from biology to physics to even social psychology.
It speaks to the interdisciplinary nature of AI and its ability to connect seemingly disparate areas of knowledge in pursuit of new insights and solutions.
Now, for our next paper, we're going to explore a technique that's been gaining a lot of attention in the machine learning community: adversarial training. It's a technique that's often used to improve the robustness of AI systems, making them more resistant to attacks or manipulation.
Adversarial training is like a game of cat and mouse between two AI systems. One system tries to learn to perform a task, like recognizing images, while the other system tries to find ways to trick or fool the first system. Through this adversarial process, both systems improve, resulting in a more robust and reliable AI system.
So it's like a sparring partner for the AI, helping it to become stronger and more resilient. I'm curious, what kind of applications does adversarial training have?
This paper, Adversarial Training for Secure and Robust Machine Learning, a comprehensive survey, provides a comprehensive overview of adversarial training and its applications in various domains, from cybersecurity to computer vision to natural language processing.
That's quite a range. It seems like adversarial training is becoming an essential tool for developing trustworthy and dependable AI systems, especially as we become more reliant on AI in critical areas like healthcare, finance, and transportation.
It's a key technique for ensuring that AI systems can operate safely and effectively, even in the face of unexpected challenges or malicious attacks.
Okay, I think we have time for just one more paper before we wrap up this whirlwind tour of cutting-edge AI research. And for our final paper, we're going to delve into a field that's been capturing the imagination of both scientists and the general public: quantum machine learning.
Quantum machine learning is a relatively new field that explores the intersection of quantum computing and machine learning. It holds the potential to revolutionize AI by leveraging the unique capabilities of quantum computers, such as superposition and entanglement, to perform computations that are impossible for classical computers.
It sounds incredibly complex and futuristic. What are some of the potential applications of quantum machine learning?
This paper, Quantum Machine Learning, a primer for the perplexed, provides a gentle introduction to this rapidly evolving field, exploring its potential applications in drug discovery, material science, financial modeling, and even fundamental physics research.
I'm particularly intrigued by the possibility of using quantum machine learning to develop new drugs and materials. Imagine being able to design a new drug that targets a specific disease with unprecedented precision, or to create a new material with properties that defy conventional physics.
Those are just a few of the tantalizing possibilities that quantum machine learning offers. It's still early days for this field, but the potential is truly vast.
Well, we've covered an incredible amount of ground today, exploring a wide range of AI research, from neural networks to language models to quantum computing. What's the biggest takeaway for our listeners?
I think the biggest takeaway is that the field of AI is evolving at an unprecedented pace, with new breakthroughs and applications emerging almost daily. It's a field that is full of both promise and challenges, and one that will undoubtedly have a profound impact on our lives in the years to come.
It's an exciting time to be following the developments in AI, and I can't wait to see what the future holds.
I wholeheartedly agree. And now we're going to transition to a topic that's often overlooked in discussions about AI, but one that is becoming increasingly important: the human-AI collaboration.
Human-AI collaboration? I'm intrigued. Tell me more. Human-AI collaboration. That does sound like a fascinating topic. Yeah, it seems like we often hear about AI replacing humans,
Right.
but this suggests a more, cooperative approach.
Exactly.
So what are some examples of this human-AI collaboration in action?
Well, this next paper, Human-AI Collaboration for Creative Problem Solving. A case study in design explores how designers are using AI tools to enhance their creative process. And they found that AI can help designers explore a wider range of design possibilities.
So it's like giving them more options, more ideas to work with.
Exactly. Generate novel ideas and even provide feedback and suggestions that can push the boundaries of human creativity.
So it's not about AI replacing designers, but rather about AI becoming a creative partner,
Right.
helping them to think outside the box and come up with innovative solutions.
That's the idea. Yeah,
That's really cool.
it is.
And this collaboration extends beyond the realm of design, right?
Oh, absolutely.
We're seeing it in fields like scientific research where AI is helping scientists analyze massive data
Yes,
sets
sifting through all that
to
data
identify patterns.
and make new discoveries that would have been impossible for humans to achieve alone.
It's like having an AI research assistant, right?
Exactly.
That can help sift through mountains of data and point out the most interesting and relevant findings.
That could really accelerate the pace of scientific discovery.
It really could. And it's not just about analyzing data either, right?
Right.
AI is also being used to assist with tasks like writing scientific papers, translating research findings into different languages, and even generating hypotheses for further investigation.
So it's really becoming an integral part of the scientific process.
It seems like AI is becoming an indispensable tool for scientists,
I think that's fair to say, yeah.
helping them to work more efficiently, make new discoveries, and share their findings with the world.
It's really changing the game.
Now let's shift our focus to a paper that explores the potential of AI to address one of the most pressing challenges facing humanity:
And that is,
climate change.
of course, one of the biggest challenges of our time.
The paper is titled AI for Climate Change Mitigation, a survey of techniques and applications.
Sounds like a good overview.
Yeah, climate change is such a complex and multifaceted issue.
It really is.
It's hard to know where to even begin to address it.
Absolutely.
How can AI possibly help with something so massive?
Well, AI alone can't solve climate change,
Right.
but it can play a significant role in mitigating its effects and helping us transition to a more sustainable future.
So it's a tool, a powerful tool that we can use.
Exactly.
And this paper provides a comprehensive overview of how AI is being used to monitor climate change, predict its impacts, and develop solutions for reducing greenhouse gas emissions and adapting to a changing climate.
A lot of ground to cover.
It is. It's a wide range of applications.
Yeah.
Can you give us some specific examples of how AI is being used to tackle climate change?
Sure. So AI is being used to analyze satellite images to track deforestation, monitor melting glaciers, and predict extreme weather events.
So it's helping us to understand what's happening to our planet.
Exactly. And then it's being used to optimize energy consumption in buildings and cities to develop more efficient renewable energy sources and to design carbon capture technologies that can remove greenhouse gases from the atmosphere.
So it's helping us to find solutions to reduce our impact on the environment.
That's the hope.
It's encouraging to see how AI is being harnessed to address this global challenge.
Yeah.
It's a reminder that AI can be a powerful force for good in the world.
It can be. It's up to us to use it wisely.
Absolutely. Well said.
Now, for our final paper,
Okay, bring it on.
we're going to come full
We're
circle.
back to human-AI collaboration.
Exactly. But this time from a slightly different angle.
Okay.
It's a paper titled The Ethics of Human-AI Collaboration: Challenges and Opportunities.
Ethics, that's an important consideration as we become more reliant on AI.
It's crucial, yeah.
It's crucial to think carefully about the ethical implications of these partnerships.
Definitely.
What are some of the key ethical challenges that this paper highlights?
Well, this paper explores a range of ethical challenges, including issues of bias, transparency, accountability, and the potential impact on human autonomy and agency.
Those are all big issues.
They are.
For example, how do we ensure that AI systems are not perpetuating existing social biases
Right.
or creating new ones?
It's a tough one.
It is. How do we make AI systems more transparent and understandable
Yeah, like opening up the black box.
so that humans can trust their decisions?
We need to be able to understand how AI is making decisions.
And how do we ensure that humans remain in control even as AI systems become more sophisticated and autonomous?
The question of control is a big one. Yeah,
Those are all incredibly important questions.
they are.
It seems like we need to develop a new ethical framework that can guide the development and deployment of AI systems in a way that benefits all of humanity.
I think that's a great way to put it. Yeah,
It's a conversation that we all need to be a part of.
for sure.
Well, that brings us to the end of our deep dive into the latest and greatest in AI research.
Wow, what a journey.
We've covered an incredible amount of ground today, exploring everything from neural networks to climate change to the ethics of human-AI collaboration.
A whirlwind tour of the AI landscape.
It has been, and I hope our listeners have gained a deeper appreciation for the transformative power of AI and the profound impact it's having on our world.
Me too. It's been a great discussion.
It has, and as we've seen, AI is not just about developing smarter machines.
It's about much more than that.
It's about augmenting human intelligence, solving complex problems, and creating a better future for all.
Couldn't have said it better myself.
So stay curious, keep learning, and join us next time for another deep dive into the fascinating world of AI.
Until then, keep exploring.